In this video class 12, we are going to discuss magnetic substances. Basically, there are three kinds of magnetic substances, which are diamagnetic substances, paramagnetic substances, and ferromagnetic substances. Let us start with diamagnetic substances. Now, these are substances which do not have any individual dipole moment at all. There is no atomic dipole moment inside these substances. Thereby, there is no question of having a net dipole moment at all. So in diamagnetic substances, remember, since there are no individual atomic dipole moments whatsoever, therefore the net dipole moment of diamagnetic substances, it's zero. So if this is the substance, as you can see, there is no individual dipole moment, thereby there is no question of having a net dipole moment at all. Let us look at its properties. Diamagnetic substances have small negative value of susceptibility. That is, psi m is lesser than 0. The value of the susceptibility, mind you, thereby gives us an idea about how likely is it for the substance to get attracted by a magnet. Since it has a small negative value, lesser than 0 of course, therefore diamagnetic substances are not attracted by a magnet at all. They are in fact lightly repelled by magnets. Also, the value of relative permeability for diamagnetic substances μr is lesser than 1. You need to remember these values because sometimes you'll be asked about the relative permeability or about the susceptibility for different magnetic substances, remember. Since the susceptibility for diamagnetic substances is lesser than 0, therefore it's like diamagnetic substances, they hate magnetic field or they hate magnets. Thereby remember, if we have a rod of diamagnetic material suspended freely in a magnetic field, then what happens is the rod becomes perpendicular to the external magnetic field. It's like they want to go away from the magnetic field. Also, in a non-uniform magnetic field, since diamagnetic substances don't like magnetic fields, therefore they move from the stronger to the weaker part of the field. Finally, the susceptibility of a diamagnetic substance is not dependent on temperature at all, remember. You increase or decrease the temperature of diamagnetic substances, the susceptibility is going to forever have a small negative value. The rise or fall in temperature makes no difference to the susceptibility of diamagnetic substances. Now to give you some examples of diamagnetic substances, bismuth, graphite, zinc, copper, gold, hydrogen gas, nitrogen gas, water, also mercury are some of the examples of diamagnetic substances, so to say magnetic field or magnet hating substances. Let us look at paramagnetic substances now. Paramagnetic substances, unlike diamagnetic substances, they have individual atoms acting like magnetic dipoles. But the individual dipole moments are oriented in all possible directions randomly, because of which the net dipole moment of the substance is 0. Let's discuss its properties now. The susceptibility for paramagnetic substances, it has small positive value. Therefore, psi m is greater than 1. Likewise, the value of the relative permeability for paramagnetic substances is slightly greater than 1. You can get the value for relative permeability if you know the value of susceptibility from this equation, of course. Now, diamagnetic substances were magnetic field hating substances, but paramagnetic substances are substances which like magnetic field. So therefore, when we have a rod of paramagnetic substances suspended freely in an external magnetic field, what happens is the rod of the paramagnetic substance gets aligned in the direction of the magnetic field. Likewise, in a non-uniform magnetic field, since a paramagnetic substance likes magnetic field, therefore it moves from the weaker part of the magnetic field to the stronger part of it. Also, for diamagnetic substances, its susceptibility was independent of temperature, but for paramagnetic substances, the susceptibility decreases with the rise in temperature. In fact, the susceptibility is inversely proportional to the Kelvin temperature of the substance, given by this relation. And by the way, this relation is called Curie's law. Now, to look at some of the examples of paramagnetic substances, aluminium, sodium, platinum, liquid oxygen, manganese are some of the examples of paramagnetic substances. Now let us discuss the behavior of ferromagnetic substances. Let me tell you at the very beginning, ferromagnetic substances are magnetic field or magnets loving substances. These substances, of course, have individual atoms acting like magnetic dipoles. But more than that, what is special about ferromagnetic substances is that atomic magnetic dipoles having the same direction, they come together inside the substance itself and form groups in a certain region of space, like shown in the picture, and these regions are called domains. As you can see in the picture, every domain has its own particular direction. But of course, every domain has a direction which is different from the direction of the other domains. Now, since the direction of every domain is different, therefore the net dipole moment for a ferromagnetic substance is also zero. But do understand one thing very clearly here. If ferromagnetic substances are placed in an external magnetic field, then all of the dipoles from every domain gets readily aligned in the direction of the magnetic field, because of which ferromagnetic substances easily gets magnetized, or very easily magnetism can be induced in ferromagnetic substances. Let us discuss its properties now. We saw that paramagnetic substances had small positive value of susceptibility. And we now see that ferromagnetic substances, they have large positive values for susceptibility, such that psi m is much greater than 0. Likewise, the relative permeability mu r is of the order of hundreds and thousands for ferromagnetic substances, such that mu r is much greater than 1. Like I told earlier, since ferromagnetic substances loves magnetic fields, so therefore a ferromagnetic rod freely suspended in a magnetic field readily sets itself in the direction of the magnetic field. You can try this with an iron nail also. Tie a thread at the center of the iron nail and suspend it freely. You will see after some rotations, the iron nail will align itself in the north-south direction of the magnetic field of the Earth. Again, ferromagnetic substances love magnetic field, so therefore they are strongly attracted by a magnet. Now, the susceptibility of a ferromagnetic substance changes with temperature according to the equation psi m is equal to C upon T minus Tc. This equation is also called Curie-Weiss law or Curie-Weiss law, whichever way you want to pronounce it, where C is a constant, capital T is the Kelvin temperature of the substance, and Tc is something called the Curie temperature for the substance. We will see what a Curie temperature is later. Now, the example of ferromagnetic substances, iron, nickel, cobalt are all examples of ferromagnetic substances, and these are also substances that are used to make a magnet. Now, let us see what the Curie temperature for a ferromagnetic substance is. If we gradually go on heating a ferromagnetic substance, what happens is the ferromagnetic substance starts losing its ferromagnetic behavior gradually. But at a definite temperature, what happens is the ferromagnetic substance loses all of its ferromagnetic behavior and turns into a paramagnetic substance. So this temperature at which a ferromagnetic substance loses its ferromagnetic behavior and turns into a paramagnetic substance is what is called a Curie temperature. Every ferromagnetic substance will have its own value of Curie temperature, of course. So to say, above the Curie temperature, the ferromagnetic substance behaves like a paramagnetic substance. We've already discussed how the susceptibility for all three magnetic substances is dependent on temperature. Now let us also see that graphically. So if you have a diamagnetic substance and you plot its susceptibility with respect to its absolute temperature, then the susceptibility is independent of the temperature as shown by this black straight line here, which is of course parallel to the temperature axis. And since the susceptibility for diamagnetic substances is negative, so therefore it is lower than the temperature axis. We've already discussed that for paramagnetic substances, the susceptibility is inversely proportional to its absolute temperature. So therefore, this is what the graph looks like for paramagnetic substances. For ferromagnetic substances now, the dependence of the susceptibility on the absolute temperature of the substance is as given by this equation. And the graph looks like this. And we can see from this graph that after Tc, that is after the Curie temperature, the substance behaves like a paramagnetic substance. That is, the variance of the susceptibility with respect to the absolute temperature of the substance is inversely proportional. And we also understand from the graph that below Tc, this region marked by 1 is the ferromagnetic region, whereas above Tc, that is in region 2, the substance behaves completely as a paramagnetic substance, and thereby this is the paramagnetic region.